All right, here's sample problem 4.3 as part of class 4. We have this loaded car. It's at rest on a track, and it forms a 25-degree angle with the vertical. The gross, disgusting, weight of the car is 5,000 pounds, and it acts at a point 30 inches from the track right here, right? So that's what they're telling us. And that's halfway between the two axles. Right here, so we have axle 1 and axle 2. Axle rows. The car is held by a cable attached 24 inches from the track. Determine the tension in the cable and the reaction at each pair of wheels. Now, I do this differently from the textbook. I'm not saying that I'm right, but I like my way better. So I am saying I'm right. Okay, I'm going to do an FBD of this. And so I make a drawing. It doesn't have to be a great detailed drawing, but you don't want to make a sloppy drawing either. And it does help to try to mimic the angle as best you can. So that's okay. And you don't want to make it too small because you want enough space in there that it doesn't get confusing. Now see, one of the loads that's applied, let's see, I want to try to get this little proportional right there. We'll call this F T. Sometimes they use capital T, but I don't particularly like that. A lot of times I'd like to make this green. I like gravity is green, so I'll try to put that in there. Under here. We'll see in a second that I'm going to break that down into components actually. The reactions on here are going to be right here and right here. And I think they decided to go with their naming conventions, and they kind of decided that this was 1 and this was 2 instead of using letters. Go figure. So that this was R1 and this is R2. Not sure I like that 100%, but whatever. When it comes to the so here's one of the big things that I decided to do. Well, for one thing, they have their they did a similar thing, but they moved their axes 90 degrees from mine. I rotated my axes, so this was X and this is Y, and I like to designate them as prime because we are so used to having the X and Y be up and down and left and right, right? So but this right here really kind of helps us. We also want to put in some of the angles, right? So one thing is that we'll find is that this angle right here is the 25 degrees, right? And if we were to look over here and over here, these are all those 25 degrees. The distance, so let me see, I wrote those in there, but they might get in the way. So putting in this right here, here's going to be our 25, and I should I said you should make this big enough, but I was trying to conserve space so I could do this all on one slide. Right here is going to be the 24 inches, and right here is going to be the 30 inches. And I have somebody calling me. I don't know if it's an important person. It's my daughter, so she's pretty important. So let's pause this for a second. I guess we will end the show, keep it, and let's pause. Okay, that was that worth it? I don't know. She needed a mug to make a muffin in the microwave. I don't know what the hell that is. All right. Back on track. No pun intended. No, there's no tracks here, but it would have been a pun. Let's see. The gravity. Okay, so the thing weighs 5,500 pounds. It would be helpful for us to make this in the X, Y prime direction and this in the X prime direction. So looking at that and looking at that angle, we could see that the weight in the X prime component right here is going to be 5,500 times the cosine of 25 degrees, and the weight in the Y prime direction is 5,500 times the sine of 25. And you want to double check on those because it's easy to get them mixed up all the time. I do all the time. Okay, so this is going to be 2003. Nope, I have them backwards. See, I mess them up all the time. 4,985 pounds and 2,324 pounds, right? So we could even, if we had made the thing bigger, okay, I know, I should have made it bigger. We could put those on there, 2,324 pounds, and then squeeze them in there, 4,985, right in there. Okay. So what we want to do is, well, one thing we could do is we could actually, and this is part of your learning process, is to observe a problem and try to reason out, like, look at it and kind of think, and like, hey, notice that in the y direction, the y prime direction, there's only two forces. There's the tension and the weight coming down, right? Because these wheels are frictionless right here. If there was friction, we would actually put them in there. But we can see in the y direction, we're totally golden. We're totally good to go. So we take the sum of the forces in the y prime direction, and I'll declare that direction as being positive here. And we see that we have Ft completely in that y, not equals, but sorry, minus 4,985, right? So we recognize that the force of the tension is 4,985 pounds, right? And I think that's determine the tension. That's one of our answers. And we don't have to give that a sign because you can't push a rope, so you don't really need to. And if we were to do something, we might go like T next to it. That's like in other classes. It's when you just the definition between tension and compression, but you can't compress a rope. I guess you could, but not in this situation. Now we want to find the reactions, and so we look at a strategy, and we could actually find it by taking the sum of the moments at either of these 2 points, like either right here or either right here, right? And I'll call those points where the wheels touch. Right there is 1 and 2. So I decided to take it about 2. Let me see, make sure I did that right. Yeah. So I won't write in yellow because that's just rude. So the sum of the moments about 2 equals 0. And so we start looking at forces here. So I'll start out with my tension, and you'll notice that that's 24 is what they told us. And that's going, if you're taking it about 2, that's counterclockwise, so it's positive. So it's that 4,985 we just found times our 24, which is the perpendicular distance to that point. And now we take R1, right? And we notice that R1 is going to go clockwise, so it's negative R1. And the distance is going to be 50, right? The 25 plus 25, so 50. And then we also see that we have the x prime component of the weight right there is counterclockwise, right? It's going wee that way. So 2,324, and that distance is going to be 25. What are these inches? Yes. And then we take a look at the y prime component, and that's going to be in the clockwise direction. So he's negative, and he's 4,985. And that's going to be times the 30 is the perpendicular distance. And if we do that, we get R1 is equal to 563.8 pounds. And it's going in this direction. And that arrow is good enough. We don't need to necessarily make it a vector as part of that. If we did, we would make it that this would be a 25 degree thing. But it depends how you want to express the thing. I guess we could do it as a vector if we wanted to. Like we could go like this right here, and we say that was 25 degrees, and that makes that into a vector, and then we can answer it if we wanted to. And then we take the sum of the forces in the x prime direction, and that's going to, that's going to be this direction right there is going to be positive, defining it, equals to 0. And looking through here, we have R2. Well, let's see. I'll start over here. R1 is the 563.8, right? And then we have a negative 2,324 is the x prime component of the weight. And then we have a positive R2, and we have no other x prime direction forces. So we get a move that R2 is going to be equal to 1,760 pounds. And that 2 is coming down this direction right there of 25 degrees. I'll make it into a vector. Now, the book did a significantly different approach to this. They decided to do a couple crazy things. I don't know if it just seems like to me it would confuse a student. So I'm not doing this on purpose, but they decided to take like the moments about like points like right there. And well, you take a look at it and you tell me. I think my way is, or the way that I've shown here is more straightforward and something. This is the approach I think most engineers would have taken. So let's see. Hopefully my daughter can find a mug to make a muffin in the microwave. That's just great. And that made an 11-minute video.